Okay, today we're going to do some application problems using right triangle trig. And the thing to remember, because eventually we're going to do law of sines and law of cosines, and those aren't right triangles. And once you learn those, you forget that you can use right triangle trig because it makes it easier. Okay, the first thing this asks us to do is find the angle of elevation and the angle of depression. Remember that those angles are always away from the horizontal. So this airplane is flying straight across. And we want to know his angle of depression to the flight tower. And we're going to go to the base because then we don't have to argue about how tall the tower is and everything else. Okay, so this is the angle of depression. Okay, it's down from the horizontal. Here's the ground. Whoop. This is the angle of elevation. All right, so if we read this problem, it says an airplane pilot spots the control tower at an angle of depression of 47 degrees. Okay, so I'm going to move my theta and change this to 47 degrees. That says angle. It looks like a 3-year-old. Sorry. And he knows that his altitude is 3,000 feet. So that's this right here. It's 3,000. 30,000, sorry. What is the ground distance from the airplane to the tower, to the nearest foot? So they're looking for this. Okay, now remember, think back to geometry and you have parallel lines cut by a diagonal. These are alternate interior angles. Okay, so if this is 47 degrees, this is 47 degrees. Okay, so when I set up my triangle, 47, 30,000, and we're looking for this. We got an opposite and adjacent. That looks like tangent. Tangent of 47 equals 30,000 over x. You multiply by x and divide by tangent. This is an exact answer, and sometimes on your quizzes and tests, we ask for that, and you don't have to do anything else. Just stop right there, okay? And then we'll say, find the approximate answer, and we'll put it in your calculator. Now, the thing is this is in degrees, so you need to go in and make sure your angles are in degrees. Mine are always in radians because I graph they're in radians. And then I do the math. So I do 30,000 divided by the tangent of 47, and it tells me it's 27,975.45. What is that? Feet? Man, you can't read that either. 27,975.45. There, that's better. Sorry, sloppy. And don't forget your units. Their application problems. Okay? A flagpole on top of a building is sitting on top of the building. So here's my building. 300 feet from the base of the building, the angle of elevation, so we're going this way, 300 feet. The angle of elevation to the top of the pole, so it's up here, is 33. And the angle of elevation to the top of the building is 31. So I have two triangles. One is 31 and 300, and the other one is 33 and 300. Okay, we want to know the height of that flagpole. So if I find this length and subtract the length of the building, I'll have the length of the flagpole. Okay, so I'm going to call this B. No, this is B. That's the building. We'll call that F. All right, because it's got the flag on top of it. All right, so the tangent of 33 equals the flagpole over 300. So you do 300 times the tangent of 33 equals F. We can do that. So let's see, 300 Oh, nope, clear. You can do that if you know how to use your calculator. Times the tangent of 33 is 194.822. Then I'm going to do the tangent of 31 equals the building over 300. So 300 times the tangent of 31 equals B. So 300 times the tangent of 31 is 180.258. But if I write those down and then subtract them, I'm going to have rounding errors. So what I'd rather you did was write 300 times the tangent of 33 minus 300 times the tangent of 31, and do the math all at once, okay? Or you can pull the 300 out of there and do the tangent of 33 minus the tangent of 31, multiply by 300, and you get 14.56 feet. Okay? What would we do it with our rounded enders? 194.822 minus 180.258, and I got 14.564. Pretty much the same. But it's always safe. This is not a bad option, y'all, because then you don't have a rounding error. All right. While riding in a hot air balloon, Taylor wonders how high she is. To find out, she chooses a landmark to the east of the balloon and measures the angle of depression to be 54. Okay, so here she is in her balloon. Oh, we have to have some strings in there. All righty, so she's up there to the east. That's this way. So she goes over here. She's looking at, let's say she picks a tree. Boop, 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 boop. Okay, the angle of depression is 54. Okay, a few minutes later, after traveling 100 feet, so she went this way 100 feet, the angle of depression to the same landmark is 61. Use this information to determine the height of the balloon. Well, if we finish this and make it a triangle, this is H, that's what we're looking for. This is X, I don't know. Okay? So one triangle goes like this, has 61, X, and H. And I can set up a ratio of the tangent of 61 equals H over X. My other triangle goes like this. This is 54. This is 100 plus X over H. So I have the tangent of 54 equals H over 100 plus X. If I solve them both for H, you get H is equal to X times the tangent of 61, and H equals 100 plus X times the tangent of 54, and I can set them equal to each other. So X times the tangent of 64 equals 100 plus X times the tangent of 50. Is that? Oh, that should be 61. Sorry, 61 and 54. Okay, I'm going to keep rolling. This is X, tan. You notice I don't have any numbers. I didn't put them in my calculator. That's 100 times the tangent of 54 and plus X times the tangent of 54. I'm going to put the terms with X on the same side, so I have X tan 61 minus X tan 54 equals 100 times the tangent of 54. Factor out your X. And then solve for X. Okay, that's calculator ready. I might want my answer that way. Now I'm going to put my calculator. 100 tangent 54 divided by tan 61 minus tan 54. And I get x is equal to 321.84. What are we dealing with? Feet? Feet. Okay? Show your work. Show all your steps. Show what you do. Draw your pictures. That's all there is to it. Have a good time. Do your homework.